Sub year 12, how's it going, everybody? Right, just popping out the chat from the YouTube video, waiting for it to start. Got 7 people waiting. Amazing. That's cool. As a lamb, you like. Okay, I can't even say that, Shaz. Can't even say it. Oh, hey, Oliver. Epicus. Chaz. There we go. Say it. Right. Okay, guys. So I can get rid of my YouTube video now that that's running. Hi, Didney, which is somebody. Hi, Marcellus. Nice to see you. Can't remember who Didney is. Didney? Can't remember. Anyway, right, guys, let's crack on. So today's lesson is on disproportionation. But before that, I'm going to run through your homework. Hey, Winkit. I'll switch my camera over as well to clip cam so you can see me. Whoop, whoop. Yeah, so cool. That's Russell, of course it is. Right. Why did you age down 5 years? You saying I'm old? Is that what you're saying? Huh, Sian? Huh? Huh? Punk? Huh? Call me old? I'm cool. I'm cool. Sorry. What? Moving on. So, moving on. Okay, so I set you guys a Redox half equation homework to get you guys practicing Moe. Age down means younger. I know, therefore I must have been old. Too old to do that, apparently. Ugh. Anyway, so I set you guys combining half equations 2. I will set half equations 1. It's the same process, so just a different sheet. I just picked the wrong one by accident. It was obviously in the list higher up. So I'm just going to quickly run through this because it's really good practice. Everything comes down to Moe. We love Moe. Some of the kids like to say moi, like when you're kissing it, because you know when you write down moi, you write that. Yeah, but then what happened was I did this a couple of years ago, and they were like, I said, oh, guys, you can either moe it or you can moire it. And then one of my year 13s started calling it Frenching half equations, and I didn't like that. So let's stick with moe. So first thing, so metal, water, acid, electrons. So the metal is any element that is not hydrogen and oxygen. So I've got sulfur, we're good. Next, water for oxygen, add 4 H2Os on that side. Next, acid. Water's done. Acid, add 8 H pluses. That's the trick. Lots of people do 4 by mistake. Bear that in mind. So 4, the 8 hydrogens on that side. Now we need to check for charge. So on this side, we have -2 because that's 0 and there's 1 of those. On this side, we have -2 plus 8. So that's +6. I need to add it to the more positive side. And I need to bring it all the way down to -2. So I'm going to add 8 electrons onto that side. And I'm done. Tick it if you've got it. Next, is it red or ox? So oxidation is the loss. Ox is loss of electrons, which is out. And reduction, red, is gain. And gain has the word in it. Yeah, so this is spitting out electrons, which means it's lost. So that is ox. Next, tick it if you've got it. So 2 marks straight away. So the marks are, just switching to green, 1 mark for the correctly balanced equation, 1 mark for identification of ox. Next one, right, so we're going to run the moe on this bad boy. So we're now going to do 1 nitrogen, 1 nitrogen, 3 oxygens, 2 oxygens, add a water. Next, 2 hydrogens, 2 hydrogen ions. Charge. On this side, it's 0. On this side, it's +2 and -1. So that's going to be +1. Add 1 electron onto that side, and I'm done. So there is it's going in, which is in the word gain. So that then is red. I like it. Now we need to combine them. So again, 2 marks, guys. 1 mark for the balanced equation, 1 mark for the red. You're doing well. Now we need to combine them. So we're going to multiply this guy by 8. So it's going to become, so the electrons are now going to cancel. So this, if I'm now going to do this, so that's now going to become 8. That now becomes 16. 2, sorry, no, 8, and then 8, and then 8, and then put them all together. The electrons cancel. Yeah, the H's all disappear from there. We're back to 8 of them. The waters cancel. They're all gone. We're down to 4. Ooh. That's weird. Tap to set up your pen. Never had that before. Go away. Go away. Go away. Final equation. Final equation is going to be I'm going to end up with they're all gone. The electrons are all gone. Water. So I've got 8. So the final answer, 8 H pluses plus S2 minus plus 8 NO3 minuses goes to SO4 2 minus plus 8 NO2s plus 4 H2Os, and I'm done. Let's check it. So hydrogens, 8 and 8. S's, 1 and 1. Nitrogens, 8 and 8. Oxygens, 8 times 3, 8, 16, 24. 4, I've got 16 there, plus 4 there and 4 there, so that's the same number. Now we can check for charge. On this side, plus 8, minus 2, minus 8. Total charge, minus 2. On this side, minus 2, 0 and 0. Same on that side, minus 2, and we're done. Winner. So there's my correctly balanced final equation. So it's out of 5 marks for that question there, guys. Okay, are you ready for the next one? Okay, I'll speed this up now, guys. We're going to get faster and faster and faster and faster and faster. So, so we're going to do them away again. Metal, water, acid. The chlorine is the metal. There is no oxygen, so no water. No acid needed for hydrogens, just electrons. 2E minus on that side. It goes on the more positive side, and that side over here is minus 2, and this side was 0. This one is the more positive. It's going on that side. Yeah, next one. Right, metal, 1 and 1. Water, H2O, but I need 4 of them because 4 oxygens, 4 oxygens. Hydrogens, I now need to add 8 hydrogens onto that side. Charge, on this side, plus 2. On this side, we've got plus 8 and minus 1. That's plus 7. Add it to more positive side and make it equal. 5E minus. Winner. Right. Identify red or ox. Oxidation is loss. Reduction is gain. Put them together. Times by 5 times by 2. Right. Final equation. The electrons are going to vanish. So that's going to become times by 5, times by 5, times by 5, times by 2, times by 2, times by 2, times by 2, times by 8. Sorry, times by 2 gives me 8. Right, put them all together. So the H's don't cancel. So I've got 16 H pluses plus 10 Cl minuses plus 2 MnO4 minuses goes to 5 Cl2s plus 2 Mn2 pluses plus 8 waters, and I'm done. Let's check it. 16 H's, 16 H's. Oh, 10 chlorines. Really easy to there. That's why you always check. That's why you always check. 10 chlorines, 10 chlorines. 2 manganese, 2 manganese. Oxygen, 8. Oxygens, 8. Charge. It's nice to balance for charge as well. On this side, 0. Oh, plus 4, 0. Total charge on that side is 4. On this side, we've got plus 16. Plus 16, we've got minus 10. And then minus 2. Total on that side is something. Plus 16. Minus 10. So let's do that one. That is plus 6. Minus 2. Plus 4. And we're good. It all balances. I like it. I like it. Tick it if you got it. 1, 2, 3, 4, 5. Next one. Metal, chromium plus water, 7 H2Os plus 14 H pluses. And how many electrons? So on this side, we have plus 6. On this side, we have plus 14 and minus 2. Minus 2. That's plus 12 in total. Get it down to the same. 6 electrons and I'm done. Next. Oh, this is horrible. 2 carbons, 2 carbons. That's my metal. Water for oxygen. 1 oxygen, 1 oxygen. That's okay. acid. 6 hydrogens, 4, so 2 H pluses there, and 2 electrons, and I'm done. So I'm now going to, so now redox, reduction is the gain of electrons, that's going in, it's being read, the other one is being lost, that's ox. Right, put them all together, multiply the ox by 3 to get it to 6. 3, 3, 6, 6, cancel what cancels. The electrons will disappear. The hydrogens, of course, those 6 vanish, and 6 comes off that, which takes me to 8. Final answer, 8 H pluses plus 3 CH, 3 CH2 OHs plus C2, CR2 O7 2 minus goes to 2 CR3 pluses plus 7 H2Os plus 3 CH3 CHOs. Let's check to see if it balances. So hydrogens, lots. 8 plus 6, 14. 14, oh, no. 7 times 2, have I made a mistake? 8, I've definitely got, I haven't times it by 3. Ha 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 ha. You see, this is all good practice, this. So 8 there, and then 6 here times by 3. 6, 12, 18. 18 plus 8 is 26. 26 H's. 14 there, plus 4 times 3, 4, 8, 12, 26. It all adds up. Nice one. So the H's do. Next one, oxygens. 3 plus 7. 3 plus 7 is 10. So I need 7, 10. I like it. That all adds up. Right, carbons. 2 carbons. Oh no, 6 carbons. 6 carbons. I like it. That all adds up. Chromiums. 2 chromiums, 2 chromiums. I like it. Everything adds up. Yeah, so now we just need to check charge. So this here over here is plus 6 because that's 0, 0, and 3 times 2. So that's plus 6. Over on this side, I've got plus 8 and minus 2, which gives me plus 6. It all adds up. That's correct. Check it and mark it if you got it right. 5 marks. 1, 2, 3, 4, and 5. Winner. Next, H plus, balance it. 2 electrons on that side. Reduction is the gain. Oxidation is loss. Next one, right, balance for metal, no metal, water for oxygen, 2. Right, hydrogens plus 4 H pluses, balance for charge plus 4 electrons onto that side. Right, oxidation is loss, reduction is the gain. Put them together, times that one by 2. So that's going to become 2, 4, and 4. Cancels, 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 cancels. Final answer. So 2 H2s plus 1 O2. Look at the complete combustion of hydrogen. I know that adds up. Winner. Tick. Tick it if you got it. 1, 2, 3, 4, 5. Winner. Next. Oh my God, this is going to be mental. Right, 3 carbons, 3 carbons. That's my metal. Right, oxygens. Water first. So 6 there. So 6 H2Os to give me the oxygens. Next, hydrogens, 12 plus 12 plus 8 is 20, plus 20 H pluses. Ouch. Electrons, 20 electrons, because 0 charge on this side. Yeah, 0 charge here, because 0 and 0. This side is 0, but 20 plus. Bring it down. So the overall charge on that was 20 plus. Bring it back down. That works. And that's oxidation is loss. That's an ox. Then we go oxygen, so oxygen to water. I need 2 waters to balance for the oxygens, then 4 H pluses, and then 4 electrons. Right, now I need to multiply this one by 5 to get me to 20. So that's now going to become 20 plus 5 plus 10. Cancel what cancels. Electrons gone. Hydrogen's gone. Ooh, water's gone. 4. Final answer. So C3H8 plus 5 O2s goes to 4 H2Os plus 3 CO2s. And it all that's the complete combustion of propane. Isn't that lovely? 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens, 10 oxygens, 10 oxygens, and it all balances because no charges are anywhere. Winner. Why is 4B red? Because oxidation is always the addition of oxygen if that's not correct. Oh, 4B. 4B, 4B, 4B. Sorry, should be, I haven't labeled that very well. All 4Bs, yeah. It's not gaining hydrogen, it's gaining hydrogen ions. Hydrogen, when it's the additional, what? Oh, hang on a sec. Oh, I see what you mean. Yeah, reduction is the gain of electrons, that gaining oxygen. Yeah, the overall equation is a combustion or an oxidation. The overall, it would be called that. You'd call it combustion, not an oxidation. But the oxygen itself is being reduced. The person that's being oxidized is the hydrogen, because the hydrogen is the one that's gaining the oxygen, Oliver. Does that make sense? Who is gaining oxygen? Hydrogen. He's going through oxidation. What's going to be happening to oxygen all the time is reduction. Oxygen is always being reduced because it's going to go to O2 minus. Good question, though. Hope that helps. Let me know if it does. Finally, right, chlorine going to chlorate 1, right, 2 chlorines, water for oxygen, 2 H2Os, right, because there's 2 oxygens, right, 4 hydrogens plus 4 H pluses. Now I need to do charge. On this side, it's 0. On this side, it's -2 and +4, so +2. Add 2 electrons. I'm done. Not sure that helped at all, but thanks for explaining. Oliver, so you need to realize that you're saying oxidation is the addition of oxygen. Yeah? And what you need, you're looking at the overall equation, Oliver, not the half equation. Yeah? If you have X and add oxygen, yeah, then you know that X is being, this is an oxidation reaction. This is an oxidation, but who is being oxidized is X. X is being oxidized because X is gaining oxygen. And you're now asking about the half equation at 4b, and the fact is no one's gaining oxygen. Yeah, you're adding it to H plus. It's a half equation, it's not the same. You need to look at it in terms of electrons. Next one, chlorine to chloride, balance 2 chlorines, add 2 electrons, and I'm done. We can put them together immediately, don't even need to multiply. How nice is that? 2 H2Os plus 2. Ah, that's clever, isn't it? Isn't that clever? Going to 2 ClO minuses and 2 Cl minuses. And that should, and 4 H pluses. I like it. Let's check it. 4 hydrogens, 4 hydrogens. 2 oxygens, 2 oxygens. 4 chlorines, 4 chlorines. All balances for atoms. What about charge? Oh, I think I get it. Thanks. Good. 0 on this side. On this side, -2, -2, and +4. They cancel. 0. Nice. Do we halve everything? Oh, you can do. Can. They wouldn't care. Good question, Sian. They won't care. By the way, I forgot to do my, that's going to be my red, because red is the gain. Yeah, and that's gaining. This one is losing. That's an ox. This one's gaining. That's a red. And that's the final one. And this rolls me straight into my lesson. Because, guys, this one. So it's out of 6. No, it's not. It's out of 30. 6, 5, 30. Guys, can you add on your scores, please? It's out of 30. Sorry, losing my mind. Why do we need to make the electrons on both half equations to be the same? Okay, good question. The reason why, Marcellus, is because you know for a fact that when you burn hydrogen in oxygen and make water, yeah, you know the equation looks like this. Yeah, and you would say with absolute certainty, why do we balance equations? Because we're looking for the mole ratio and so that the mass adds up. Agreed? Well, the one thing you never see from chemical equations is electrons just floating around willy-nilly. Did I just say willy-nilly? Oh dear. It's a very old term. I apologize. My dad used to say that. Don't worry. I've seen a doctor about it and I'm taking medication. But you don't just have electrons wandering around, Marcellus. The electrons, what we realize is that almost, not always, but nearly always in chemical reactions, electrons are being exchanged. You don't have you don't have leftover electrons. The reactions are happening because the electrons are trying to become stable. So it's happening, it's multiplying because the electrons cannot just be left on their own. They're not going to be lost. Yeah, they're either exchanged or shared. So you must make sure that there are no leftover electrons. So I'm assuming, Marcellus, that from your question that you've got every single C wrong. Yeah, I'm assuming you've got all of these wrongs except for maybe the last one, which didn't need a multiplier. Yeah, so don't worry, you've got another one of these coming your way anyway. Another sheet, redox balancing, redox is 1. So let's see how the scores are getting on. Oliver, 30 out of 30, well done. Russell, 28 out of 30, outstanding, well done. Doing well here, guys. Be nice to see lots of scores going in. You can also add your Oxy state homework as well in. Right, and this does roll me straight into my next lesson. I'm just going to wait until all the scores are in. I'm just going to go, guys, I'm just going to go and grab myself a cup of water. Give me a sec. No, it's fine. They're filling in scores anyway. How you guys getting on? Still missing. Oh, Ava and Jim Journey now disappear, don't they? Delete row. Ah, so sad. Delete. There we go. So just Shazza to add his score in now and Wing Kit on the last one. Any questions? No, not so far. That's okay. Let's go back to there. Oh, look at that. Fantastic. Cool. So scores are all kind of in. Right, I'll continue with my lesson. So today's lesson, folks, the title is Oh, why don't I make my pen a bit smaller? There we go. Disproportionation. I know, right? What a ridiculous word. Thanks, chemists. Like, I love chemists, actually, most of the time, because when they name things, it kind of makes sense to me, and there's usually some kind of derivation from Latin or Greek, and there probably is from this somewhere, but the word is just grim. So first of all, we need to define it. So we've been talking about redox in terms of oxidation and reduction. Well, so why is this one so special? We need to define it. Definition. Disproportionation is a redox reaction where the same species, that's right, you've got to use the word species, what a horrible word, the same species is both oxidized, I'm first going reduced because of red ox, is both reduced and oxidized simultaneously. Simultaneously. So what does that look like? And the great thing is, what's hilarious about the worksheet was it rolled me straight into my lesson today. Because if you look at this particular equation, what you realize is chlorine is in an oxidation state here of 0 because it's an element We know the definition of oxidation state is the charge on an atom within a compound. So in this case, it's not in a compound, it's an element, which means it must be 0. So if they ask you to explain this, the answer can be two things. By definition, I absolutely hate that. Tells me absolutely nothing. Yeah, but I would actually prefer to say because it's an element. Yeah, because it's an element. Yeah, and elements have always got 0. Now we look at chlorine in here. So on the chat, please, can I now have the oxidation state for chlorine in that one? And can I have the oxidation state of chlorine in this one, please? Off you go, folks. Impress me that you can still do your oxidation states. What are the two? You can do them as X, comma, Y in your answer. Let's see who gets it first. So this one's X. And this one's Y. +1, -1. Thank you very much, Shazza. No, wait. No, you're correct, Shazza. Let's take them apart. So we've got ClO-. The overall charge is what we know that O must be bringing 2- because it's not hydrogen peroxide. To get to -1, so we need to equal -1. Oxygen brings a 2-. So the chlorine must be bringing a +1 to get me to -1. So +1 in brackets plus brackets -2 gives me -1. There's the maths. Yeah, and this one is just chloride, which is -1. Well done, Shazza. Nice and quick there. Very impressed. Good job, young man. So we've got +1 and -1. So the chlorine here is +1, and the chlorine here is -1. So the chlorine is actually going through simultaneous oxidation and reduction. Cl2, let's actually do this equation and balance it, forming ClO- and Cl-. I'm going to balance that to 2, 2, 2, 4. Oh, I like it. And 2 electrons that actually, 2 H pluses. There we go. Let's just stick with that for now. There's my first example of it. I love the fact that no one else contributed on the chat. Thanks, guys. Thanks, guys. Thighs. So we're going from an oxidation, oxy state, oxy state of +1, no, of 0, of 0, going to an oxy state of +1. Oh, so I agree with Shazza. So that's going up. Now we're going to use what's called the Redox Ladder here, folks. Redox Ladder. It's a nice trick. So the Redox Ladder is just an imaginary ladder. And the middle of this rung, so imagine you're standing up. Yeah, so if you're standing up, your arms are here, yeah, legs there. And if you hold your arm out, so this is me doing the Redox Ladder, that there is oxidation state 0. Yeah, it's like I can see the rung on the ladder, just level height with me with my arm. So if I now do, this is where I can't actually see what you guys are seeing, and it might be useful to see if it's working. Yeah, so that there, this here is the oxidation state of 0. And if you go down, what I'm imagining is, I'm imagining that I'm measuring like the height of somebody, yeah, like a midget. And as I go down and say, oh, he's being reduced in size. So if you come down the ladder, you're being reduced. Yeah, and the reduced is -1 and -2. Your number is being reduced in size. That makes total sense. Yeah, whereas if you're climbing, if your arm is going up, yeah, +1, +2, then you're being oxidized. Yeah, you're being oxidized. The reduced one makes the most sense. So I just imagine that there's 0. Oh, it's coming down in charge. That's being reduced in size. The opposite must be being oxidized. So in this case, I look at this and I go, oh, so that's 0 at chlorine. I'm just going back to my thing so you can see whether or not, yeah. So 0 at chlorine, and then it's going to and it's going to +1. Oh, it's being oxidized. It's climbing the ladder. So that there is oxidation. The next one is to say, so let's do that one in red. I like that. There we go. So the next one is what's going on with another one? Well, it's starting off at 0 and it's ending at -1. Well, this is just a replacement of oil rig, right? Yeah, it's just looking at oxidation states particularly rather than having to track electrons down, Oliver. Yeah, I just want to be able to do this without having to look for electrons. I don't want to have to split this into a half equation to work out what's going on. I can just look at their oxy states and decide what's going on. And this one's being reduced in size, so that's red. Yeah, it's not a it's an additional tool. It makes things easier. If someone says +2 to +4, I go +2 +4, oxidizing. Yeah, if someone says -8 +6, oh, -8, wow, that's really low. -8 +6, that's being massively oxidized. Yeah, I'm just using this clever up and down method to be able to make it easy for me to identify red and ox from oxidation states. Yeah, really handy. So what that means is the same species, yeah, Cl2 species is both oxidized. Don't like it being in green. Such a nerd. Yeah, Cl2, both oxed and reduced, and red. Red should be in red, and that's really smart. Cl2, both ox and red simultaneously. Simultaneously. Too many words. Too long. So that one is your first example of a disproportionation. Yeah. And there are lots of this. So being able to recognize it is spotting when there's one person on the left and it's forming two people separately. Let's look at some more examples of this. There are loads of these. So the first thing I can do is tick off my first learning objective. I think you guys now understand what's going on. The same person is being split into two people. One's where it's been oxidized and one's where it's been reduced. Yeah. So let's now start recognizing it. So let's just do more examples. There's loads of these. Yeah, let's have a look. So example number 1, #1. So we've got hydrogen peroxide going to oxygen and water. Balance the equation. Right, so 2 hydrogens, 2 hydrogens. 2 oxygens, ooh, 3 oxygens. Half. Winner! I love halves. Oh my God, when I got told when I started studying A-level chemistry and they said, by the way, guys, you are now allowed to use halves, I was like, oh my God, are you for real? I nearly wet myself. Like I was that excited. Like, oh my God. But please remember, only tend to use halves for elements. Don't use halves in compounds. You'll make a mistake. Stick with halves with elements. Oxygen is an element. I can use a half. I can use fractions. Yeah. So anyway, how is this disproportionation? The reason being is the oxygen here, the oxygen is in an O1- oxidation state. This is an unusual state for oxygen to be in. And what it's now becoming over here, this is where I need to try and get my color coding correct. Going over to here, it's becoming O2- in water. -1 going further minus, that's being reduced. See what I did? So -1 is there, like there's 0. -1 is here. Wow, -2. It's going down even further. That's being reduced. There's red. See what I did there with the red pen? See what I did? The next one is what's it also going to? Is also going to 0 here in oxygen, because that's an element. So it's also going there, and that is going to be the ox, because it's gone from -1 to 0 to dead level. It's climbing. It's climbing, so that's the oxidation reaction. Yeah, I'll put the 0 up there. So this is also a disproportionation. And you can see this because one species, and you can see the oxygen being split into different compounds. So it's suggesting that oxygen is going through disproportionation. Next, number 2. Let's go for the next one. Let's go for Let's go for, we've already done the chlorine example. And then let's do NO2 going to form N2 and NO3 minus. There we go. Now, isn't that clever? That's a nightmare, that is. Absolute nightmare. So the problem is now, you see, I've gone and really made this tricky for myself. Because I ought to give you, I should just give you entire equations rather than, it's a bit of a nightmare, this. Okay, let's try that again. N2 reacting with water to form, I'm going to make a mess of this now, guys, to form N2 and HNO3. I'm going to have to do all kinds of funky stuff here to make this work. Eek. I shouldn't make them up really like this, because I'm going to have to do all kinds of funky stuff here. But you're going to get given an equation, an entire one, yeah, whether or not it be true or not. Yeah, the problem is I should be trying to find ones that I know of, and I do know a few in my head, but I don't know, whatever. So 2 nitrogens, let's do that, right? But then the problem is that's not going to work, is it? Right. Oh, the problem is not making this. Okay. Disproportionation reactions. It's just easier for me to do this. I can actually build them. That's a good one. Like that one. Yeah, let's take that one. That one's easy. Is there a nitrogen one? There'll definitely be a nitrogen one somewhere. Nitrogen does it, you see. I know it does. Spot a nitrogen one. Spot a nitrogen. That's the Spot the Nitrogen song, by the way, if you're wondering. Big hit in the 60s. No. Yeah. Why, hello there. Hello. Told you there was one. NO2. Winner. Wow. That's a nightmare. Anyway, yeah, can, right. Ooh, blimey. It's not very nice. 2NO2. I'm going to make my 2 NO2s plus 2 OH minuses goes to NO2 minus and NO3 minus? Is that what it was? Yeah, and water. Okay, fine. Okay, so the key thing to spot here is recognizing that there's one nitrogen going in here in one compound. It's not in the other, and it's forming 2 compounds. This has a very high likelihood of being a disproportionation. It could actually simply be the fact that I'm getting 2 oxidation products or 2 reduction products, so I'm going to have to run it. So what I'm now going to do is work out the oxidation state of each nitrogen. So over here, the oxidation state of nitrogen is it has an overall charge of 0, O2 minus times by 2, which is 4 minus, which means that nitrogen must be in a +4. Right, I'll just put +4 there. Thank you. Next, so this one is O2 minus times by 2, so 4 minus, and I'm trying to get to -1. That nitrogen must be bringing +3. Hello. Next, so I've got mine O2 minus times by 3 gives me -6, and then I've got an overall charge of 1 minus, which means that must be bringing +5. Done. I like it. I like it a lot. Okay, so +4. Holy moly, that's high on the ladder already. +4 going to +3. That's being reduced. There's my red. That there is coming down red. And then +4, +5. Holy moly, that's being oxidized. Booyah! Boom. That's being oxed. And it's the same species being oxidized and reduced simultaneously. So it is now a disproportionation. Nice. It's always a good one. Okay. Should we do another one? Just for fun. Can. They can do, copper's a good one. Copper's a really good one. Example number 3. Copper, CuCl going to Cu plus CuCl2. Balance it. I think we're done. Winner. So, is this a disproportionation? The chances are very, very likely. I've got copper appearing in one compound at the beginning and appearing in multiple ones at the end. What we're now going to do is say, what is the oxidation state of him here? Well, I've now got Cl1 minus from the periodic table. There's no overall charge. Copper must be in a +1 oxidation state. It is an element, so 0. Next one, Cl minus times by 2, 2 minus, no overall charge. It must be bringing +2. So we've got +2 here. Right, get rid of all my working. Don't need any of that now. Right, get rid of all those as well. So now we can say from +1 to 0. So hang on, from there to there, +1 coming down. So that one's being reduced. That's red. Yeah, the next one is +1 going to +1 going to +2. That's climbing. That's ox. Yeah, there we go. And it is a disproportionation. I like it. It's also a thermal decomposition. Yeah, it is annoyingly. It is actually. No, you wouldn't call it that because you're taking one compound and forming two. It is a thermal decomposition. It is. You'd call it a disproportionation because it's more special. It's hard that. I should note a bene, copper 1+. It's colorless. Yeah, I should actually mention that as an A2 note. Guys, spoiler alert. This compound here, this is A2 note, see later notes. CA2 notes. Yeah, but compounds containing copper 1+. Copper 1+ compounds are colorless. Compounds are colorless. A2 spoiler, better learn that. It's a nice little note penny, that one. Anyway, so the next thing, so now what we can do is I can go to my learning objectives and I can say we can recognize it. Yeah, we've got lots of hints and tips now to be able to recognize it. The one thing turning into multiples, good hint, and then running the oxidation states and using the ladder to be able to then decide if it is a disproportionation reaction. It might just be the fact that it could be an oxidation to produce two oxidation products. It's possible. But like I said, the oxidation states don't tell you. So now what we need to be able to do is split them. This is much, much harder. I've suddenly realized I've got another lesson now. Guys, oh, blimey. So splitting these equations, I'm just going to do one example. So what you now do is, in order to split a disproportionation, all you do is once you've found the two different equations, you just write them down independently. So all I now need to write down, let's go for, let's stick with this one. So if I'm going to split this into two, what I'm going to do is let's do the red, since I'm going to say split. Split. So I'm going to do the red first. So the red equation was H2O2 going to water. Now I can just balance it with Moe. Yeah, I can just Moe it. So metal, none. Water for oxygen. Oh, perfect. Hydrogen's acid. Oh, other side. 2 H pluses. And 2 electrons. I'm done. I've just split it. Next, now that I've done my red, I now need to do my ox. Just find the two people. Hydrogen peroxide going to oxygen, going to half O2, and balance and Moe it. So metal, there isn't any. Water for oxygen, it's already done. Hydrogens, 2 H pluses, and balance for charge, 2 electrons, and you realize you get the two half equations from the process. So I know I've rushed that bit at the end. It's the end of the lesson, guys. I will leave you be now. I hope that made sense. I'm going to set you a homework to do this. It's hard. Right, guys, it's been, there we go. It's been really good to see you guys. I hope you found it useful. I will set the homework on the class. You're going to have two homeworks. You're going to have one, which is another 6 questions to do Moe on half equations, red and ox. And then you're going to have a second sheet, which focuses on disproportionation. And you will be able to decide whether or not they are, yay or nay, and then split them when needed. I'll see you guys soon. Have a nice rest of your day. Bye, guys.